this morning.
So
So I thought maybe they come pick up there along the way.
Oh.
Two. We're getting it right. 1, 2, 3, 4, 5, 6. But maybe he's still sleeping.
Yeah. I was always on the bed.
Huh? When you texted that time?
Yeah.
1, 2, 3, 4. 1, 2, 3, 4, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 6. Mic check. 1. Okay.
Morning. How are you doing? No, not set up. Do you need it on a flash stick or can you connect this? This morning. I do move around a lot.
Okay.
Thought I'd just warn you.
No, that's fine.
Do you want me to stay in one place?
We will just give you a lapel mic for the sake of the video stream for the other venue. so I'm not sure where you
Where
can
we're going to attach it.
clip it.
that's
Yeah, that's a bit of a
because I don't have the...
dilemma.
We could put it on my trousers, but then my dress would be up like this.
This can clip like maybe into a piece of material somewhere.
I haven't got anything.
Yes, I see you are not.
I'm streamlined.
You can't put it in. Are you wearing pants of some sort?
Yeah, but then this is going to stand up. Do you know
It
what I
won't be
mean?
so bad. It's very long actually. So it actually won't. I don't think it'll be a problem.
It won't attach to
Also,
this.
we
hey?
can.
It won't attach to here.
Maybe. Would you be comfortable with that around your neck?
Well, it's alright. It's better than holding them up,
Okay.
I think.
But however, this is just for the live streaming. This is not for the venue's audio. So you still probably
Still need the mic.
Still need a mic. Is that okay with you?
Nice to me.
Yes. Just for the live video stream.
So it's not on at the moment, okay? No.
It actually is.
So shall we put it on just now?
We can put it on so long and
Then turn it off.
mute it on our side. Yeah.
Okay, you decide where it needs to go.
Sorry, it doesn't look extremely elegant.
Doesn't matter. I'm encumbered by technology.
Unless we could put it on the back of your pants and just take the cable through the back of your neck if you want. But that's up to you.
That sounds complicated. I think I might just leave it. And so, yeah. Do I need to just turn this off for the moment?
Leave it on, we can turn it off now.
Okay.
So let's turn it off here. Just remember to please turn it back on again. Should you take this? Yeah, it's a little bit in the shot, so back.
Hello. Like, just normal. Okay, good morning. Can you hear me?
Yeah. Check everything's okay.
Do you want me to say anything else?
No, I think that's
That's all right? Okay. Good morning, gentlemen. How are you today? Morning, Ravi. How are you?
Fine.
Good. Thank you.
I'm all right, thanks, and you?
I'm introducing you.
Are you? Great, thank you. How do I get this back to the other thing? Did you go to Addo yesterday?
Yes. Oh, we enjoyed it.
Was it good? Did you see elephants
Oh, even a lion. I'll show you photos. Lion lying
in the road? Yeah,
two of them.
yeah. They do that. The males with the,
Yeah.
yeah.
Really? So they used to just lie in the road?
Yeah. I belong to because I live close, I belong to there's a group on Facebook for Addo. And most of the photos of the lions are on the road because it's easy for them to walk, you know.
Yeah. And people walk that spot.
Yeah.
They don't move.
Yeah. No, they don't. They just lie there and go.
No. The people now, the cars.
Yes. Oh, no, you're right. They just sit, don't they? Yeah.
They sit just a little bit.
Yeah. Oh, that's good. I'm glad you saw things.
Yes. So there's lions, most of the animals.
Okay, good. Nice. Can I ask you, I've got my own timer, but can I ask you to do me a 10-minute thing?
You have the entire 1 hour.
Yes.
So at 50 minutes, you want
Yeah.
to show.
Yeah. I have a feeling I might be finished by then, but let's see how it goes. I've got to make sure that I slow myself down and talk slowly.
Supposed to have a short meeting. Now I'm staying away from the council meeting.
Are you?
Yeah. What meeting can you hold now?
Sorry?
What meeting can you hold?
Yeah, exactly. That's productive. Yeah,
No,
exactly.
they can hold it. I'm supposed to be here. It's for the entire hour meeting. That's why I told the president, let's do it after the meeting. Because I also don't want to, I need to keep time to start on time. So we go to the toilet and come back.
Sorry?
You did this one before at Eastern Cape South, isn't it?
Yes, I did. So I've got to slow myself down
Yeah.
and see if I can fill the hour.
Serious? Okay, I'll take a few minutes at a time for announcements.
Yeah, Bussi's just coming because she's gonna introduce.
Who's
But
introducing?
Bussi's introducing, I think.
Who?
Bussi.
Who's Bossy?
Bussi from KZN.
Oh, Boosie. Boosie.
There's a whole bunch of stuff here. I don't know who this stuff belongs to as well. There's a whole bunch of, you know.
We just give 2 minutes of the time, just for general announcements before and yeah, and I'm gonna go set some things to do, get some tickets done up and whatever else, finalize that, and then yeah. Okay. Okay.
Yeah, you can. You're welcome to take time. It's yeah, it is that one. Yeah. That away.
So, Jimmy.
Yes.
Dit vir jou vir vandag. Vandag. En nou het ons fine.
Do you know what? It's weird. I've done it so many times, and I'm still a little bit nervous.
But that's a good thing.
It
Then
is.
it's the adrenaline,
The energy,
kicking, and
yeah.
the energy and whatever.
Somebody also told me once that it's also good because it means you're never complacent. If
Yeah.
you're nervous, you're never
You're
complacent.
Yeah, and that is good.
Yeah.
So I'm looking forward to this. I'm doing a talk in.
I'm just
November.
covering this
Yeah,
up because
so
the
now
mouth
it's
is on.
24,
I'll
we
talk to you
start for 6
later.
minutes. So if you want to start your singing for 6 minutes, you got your time for singing now.
So I talk about the progression rules, but the kind of thing where you just passed on. But I thought this will be a nice, it is another dimension to the idea of progression.
Yes, yeah,
So,
yeah.
so I'm looking forward to what you are
Okay,
going to
good.
say.
All right. Just talk it, turn it off, yeah. Is it on now? Oh. I will sit here for 5 minutes.
somebody took their phone and walked off and went down the staircase. But because the phone was not returned to the section, this hospital was on the page. The footage showed that the person was
No.
Good morning to you all, everyone, morning. Today is day 4. And we've done excellent so far, we're doing excellently well so far. Alright, so today we were all fired up when we heard Professor Feza, isn't she? She gave us lots of things to think about. And she said we must look in the mirror all the time. We know how beautiful we are, aren't we? Aren't we all beautiful? Yes. So, just a few announcements for today. Number 1. Everybody in the Protea hostel must please remember to hand in their door cards to the security at the gate or the students. Now, I'm not too sure who's in the Protea hostel, but please don't forget to hand in your cards. Okay, your door cards. Then, tonight, don't forget those of you who bought tickets for the gala dinner. The gala dinner is in the tent starting at 7 o'clock. And the tent at 7 o'clock. Now, those of you, those of you who are in the hostel and are not going to the gala dinner, your dinner is served in the Melody hostel. The Melody hostel is you walk through past 123, you walk past here, there's a hostel, and you ask anyone there, where is Melody? Okay? The Melody hostel, you can have dinner over there at 6 o'clock. For the gala dinner, you will not fill out entry if you do not have your gala dinner ticket. So please bring your gala dinner ticket with you. Okay. For the Melody, I think we will start dinner there at 18:30 at 6:30. But at 6:15 already you can start walking towards Melody for those who are not going to the gala dinner. Then, certificates. You all are here and you must have proof that you attended this AMESA Congress. Your certificates are available in building 11 where you did the registration. We will do it the same way. Within 2 minutes, you get your certificate. You understand? We have the tables over there. You know the names, your surnames. You remember the last time when you were registered? Or you got your name tags when you registered? You go back to the table. You see your number. You collect your certificate and you walk out. Everything is in an envelope. You must just collect it and sign it. You cannot collect for a friend. You cannot collect for a friend. Your friend must go there themselves. Okay? We want to see you when you collect your certificate. Then, yesterday we had an unfortunate incident that in this room a cell phone was mistakenly taken. But you see on top there is cameras. We have the full view of the person who took it. However, we are not going to approach the person. I said the person mistakenly took it. Okay? And mistakenly took it. The person is intentionally going to return it. And he can give it to the help desk. So please, we know who you are. We're not going to approach you. We don't want to call the security. It will be embarrassing. And our job here is not to embarrass anyone. But a fellow brother or sister, I'm not saying what it is, has taken something by mistake. So please return it to the help desk, my brother. You know, or my sister, you know who you are.
I'm guessing it's a brother.
All right, thank you. The memorabilia lady has told me to make the announcement that some of you were ordered very late, the VL numbers and whatever else. You can please collect the memorabilia from this afternoon when you collect the certificates. Then you can go to the memorabilia office as well to collect that one. There are also some memorabilia for sale still. I think she said she got some scarves and caps, and I think she's got an order of about 40 beanies. You know what's a beanie? I think she's only got about 40 beanies that she said she ordered that are for sale. Other than that, I think we are good. Today's the last day. Not the last day, the second last day. Tomorrow's the last day. I trust you all that went on excursion, saw some elephants and some rhinos or some lions that went to the Addo. And those who went to Bay West, I hope you still got money left on your credit card. And those who went to the city tour, I hope you put your feet in the water by the beach. Okay? Thank you very much. Over to you, Pussy.
Good morning, ladies and gentlemen. Without wasting time, it gives me a great pleasure on behalf of the National Council and the local organizing committee to introduce a wonderful woman, Dr. Debbie Stott. She's a passionate woman in primary maths education. Dr. Debbie Stott is a senior researcher and the After School Maths Club coordinator for the South African Numeracy Chair Project at Rhodes University in Grahamstown. The project works with a number of intersecting communities such as teachers, learners, families, and researchers to enthuse mathematical passion and learning. She is also involved in the project's work with the broader community, such as family maths events and parents talk. Ladies and gentlemen, here is Dr. Stott.
Thank you, Lucy. Okay, good morning, everyone. Can you hear me? Yes. Kwemora Molweni. Okay, so my title, as you can see, which you've been looking at for the last 10 minutes, is about progressive development and profiling. So what I'm talking about is profiling for learners, okay? And I'm going to particularly be talking about progression spectra for profiling, and I'll unpack all that in a moment. First of all, I want to say how honored I am to be here talking to you today, and I thank the AMESA executive and the local organizing committee for inviting me to talk to you today. I want to just link back to the conference theme of restoring learner dignity. So yesterday, Professor Feza said that she was urging us to all try and get our children to get to a 50% pass mark. Okay? So I think from that point of view, if we can, restore learners' dignity and make them feel that they can do mathematics by getting a 50%, that's great. And that's what I wanted to focus on today, is how can we get the learners from the 30, the 10%, how can we get them to a 50% pass? Or even more than that. So if you were in my long paper the other day, you would have seen I presented some information, some data from learners and showed how they progressed in an after-school maths club and how they went from maybe getting 10% for an assessment to getting 60%, 75% for an assessment after participating in a club. So today, though, I'm not talking about clubs specifically. I'm talking about the broader work that we do in our project and looking specifically at this idea of progression. Okay. So, does any of this on the board look familiar? How many of your learners still use these types of methods in your class? Let's just have a show of hands. If you've seen this in your classroom, whether you're a high school or a primary school teacher, let's just see if it's... Okay. That one at the top left is a bit worrying, okay? Because this kind of method works well for learners when they're learning in grade 1 and grade R and grade 2 with small numbers. But look what happens when we have a thing that says 305 minus 97. How on earth do you draw 305 tally marks and keep track of it, and then try and subtract 97 to get an answer? It takes, no wonder our learners never finish a test, eh? Because it takes them 15 minutes or half an hour to do one question, okay? So this is the type of thing that we see a lot. Obviously, we are all trying to push our children to get beyond that. So let's just have a look at some of the background to this. There's a lot of literature in our South African research space and in the public space that says our learners are trapped. They are trapped doing those tally marks for whatever sum. And what happens is, as we saw yesterday with an example as well that Professor Feza put up, is that the children, they lack flexibility and fluency in doing something, okay? Because they only have one way of approaching a sum or a problem, okay? So when they're working with their 4 operations, addition, subtraction, multiplication, division, they don't have any other way of doing it, because they don't understand the rules, or the thinking behind another way of doing it, okay? We all know this. So the thing that I'm focusing on today is 2 aspects of mathematical proficiency. There's actually 5 aspects that make up mathematical proficiency from Kilpatrick and so on from 2001. But I'm just focusing on 2 here. And I'm saying that these 2 are particularly connected. That if you want to be able to do things procedurally well, you actually have to understand them. And if you do things procedurally well, you can also build up your understanding. Okay, and I'm going to keep coming back to this, these ideas of conceptual understanding and procedural fluency as I work through the presentation. the thing with conceptual understanding is about making connections between what we already know and what we're learning. And I think that's one of the things that our children struggle with, is that we say to them in the classroom, okay, today we're going to do subtraction. And for them, subtraction is a standalone topic. Yes? They don't think, oh, subtraction, it's the opposite of addition. Or maybe it's got something to do with division. Or maybe it's got something to do with the word difference. They go, oh, okay, subtraction, little box. So one of the things that we can do, that is one of the easiest things to do, is to help children make connections between things. So that they don't go, when they look at a sum, they panic and go, I don't know if this is a subtraction sum, if it's an addition sum, I don't know. Okay? And rather look at it and say, let's see if I can make sense of this thing. Okay, so there's a lot of research in South Africa that shows that our classrooms work with either counting methods, so that's tally methods, counting things in ones, and rote counting, or children recall things. That's recalling facts, recalling rules, recalling procedures, and trying to stuff all of that information into their heads and retrieve it when they need to. So there's actually a missing piece, and this is working on the understanding, is that our children need a strong sense of number within numbers, and what's actually called number sense. Okay? And this is about making connections between things. So that big missing piece is where we can help. So I want you to just take a few seconds, and I want you to think about what you know about the number 9. Okay? When I say to you, what's number 9, you might say, oh, it's 4 plus 5. Okay? Take a few minutes to think about what you know about the number 9. Talk to the person next to you if you want to. Okay, all right. I can all hear you talking about the number 9, which is great. In an audience like this, I'm not going to ask for feedback, okay, because there's too many people. But here's some of the things that you might have said about 9, depending on if you're a primary teacher or a high school teacher. Okay? There's some things. Okay, so I'm going to ask you to try something when you get back to your classrooms next term. Yes? I'm going to ask you to ask your learners what they know about the number 9. Okay? And see what they come up with. So put it on your blackboard, put a big 9 and say, what do we know about 9? That will give you a really good indication of your learners' number sense. Okay? If you're in a foundation phase classroom, most of your learners' responses will be about addition and subtraction, probably. If you're intermediate phase, you might get some multiplication, you might get some division, you might get some stuff about odd numbers. If you're then in high school, you might get a little bit more. Okay? But the things that they leave out will be quite interesting for you as a teacher. Okay? What normally happens when I do this with the kids that I work with is that somebody says, Ma'am, can I do subtraction? Can I do division? Can I do this? Whatever you want, okay? And then they start getting very creative. It's a very easy way to see what your children know about numbers, okay? Why do we need to know that? Because we need to be able to work with numbers and to pull them apart and to examine them in lots and lots and lots of different ways. Okay, so it's a really nice little exercise for you to be able to do. Oh, I've lost my diagrams. Okay, never mind. I will tell you what they say. Okay, so I want to just expand a little bit on number sense. Number sense is about working flexibly with numbers. Okay, so that when I say something like 9, all these ideas come to my mind. Okay, I don't just think about 9 as being 8 plus 1 and I'm stuck at 8 plus 1. Okay, I can think and visualize that 9 is a whole bunch of different things. The other types of things that are about number sense is about being able to add 10 to a number, add 100 to a number, multiply by 10, multiply by 100, double and half. Know your 10 times table and your 5 times table and your 2 times table, because those are about doubling and so on, okay? Is there a relationship between multiplication tables? There are actually relationships between them, and it's about understanding those connections, okay? So for a number sense approach, if you can push things like doubling, halving, multiply by 10, divide by 10, divide by 100, and so on, your children are starting to work flexibly with numbers without calculating. Now that's the key thing. They are looking at patterns and not having to calculate with paper or pencil or calculators. The calculation's going on up here. And that's what we want to try and to develop. So rather than a whole bunch of rules being stuffed in the head, we're wanting to have ways of working with numbers that are flexible, that we can have in our minds that are going on, so that we can make numbers. We can be flexible with them. Okay, so sorry about the pictures. Okay, so I went to the Foundation Phase Teacher's Handbook. So I know if you're a high school teacher, this actually still is relevant. And on page 26 it says this: too many children leave the foundation phase operating at level 1. Level 1 in the handbook is concrete one-to-one counting. They leave the foundation phase with that. Too few teachers know the level at which each of the children in their class is working. That's where I'm going to be focusing today, is that second item. Too few teachers are making deliberate plans to support the progression of children from one level to the next. And that's again where I'm going to be talking. Okay? So at the top we've got a problem, and then I'm going to try and address those two in the middle there. And the last one says, too many teachers believe that they are helping children by limiting the number range in which they are working. Now this is one of the wonderful things about working with numbers and doing number sense, is that you can push children to work with bigger numbers and to see the pattern, okay, without limiting their number range. So when I work with kids and I'm doing a doubling exercise, I might start with, say, okay, double 100, double 200. And then I'll jump to something like double 1,000 if I'm doing foundation phase. And they start looking at me like this. But I say, what's the pattern? Double 100 is 200. So what's double 1,000, do you think? 2,000. What do you think would double 1 million be? Whoa, Debbie, no. Well, 2 million, wow. What do you think double 10 million would be? And they're doing it, okay? Their eyes are like this because they're saying the numbers are too big, but they are doing it because you're establishing a pattern with them, okay? They don't necessarily at that point have to do calculations with those numbers. But they can see that the numbers beyond where they're working at the moment, they carry on. Numbers get bigger. Okay, so let's see what we need to try and do. So many of the current assessments that we have in our schools, especially the ANAs, which I'm not sure if they're coming back or not. Do we know? No. They don't give us any diagnostic information about our learners. They say if it's a grade 6 ANA, they say this child cannot do grade 6 work. But what they don't say is, where is the child? Is the child at grade 2 level still? Or is the child at grade 4 level? We don't get that type of diagnostic information from the ANAs. It just tells us that they've failed that grade. Okay, so like I've said, there's a lot of research that says we need to progress learners. And the problem is for us as teachers is that it's difficult to choose activities to do in the classroom and to remediate and to help and support children if we don't know where they are. So if they fail the grade 6 ANA, we sit there looking at it and go, okay, well, let's do some error analysis, but I'm still not sure which level I should be teaching these kids at or trying to remediate. Okay, so the error analysis tells us what they're doing wrong. Doesn't necessarily tell us where they are in their thinking and their mathematical process. Okay. So it's hard as a teacher if you don't have that type of information to try and help and to support. So I'm going to quickly look at some of the ways that this has been done around the world by looking at this progressive progress. A lot of people call it a learning trajectory, a learning pathway. Something that you start on when you start school and then you move on to it by the time you leave school. What's interesting is that this lady, van den Heuvel-Hazen, I can never say it properly, she says what is learned in one phase is understood and performed at a higher level in a later phase. So when we start on a learning trajectory, all the stuff that we do at the beginning becomes foundational. And then we are building on that all the way through. If that foundation at the beginning, or a little bit along, is not strong, it falls apart. What also happens is what we saw yesterday with Narcisi's presentation, is that if the child doesn't understand as they've moved along the steps, they go back to the last place that they did understand. So that child solved that problem yesterday in an arithmetic way, not algebraic, okay? Because he or she decided, I don't understand, I've had no solid foundation here, I'm going to go back to the last place where I felt comfortable. And for a lot of kids, that comfortable place is right back to the tally marks. Okay, right back to the very beginning. Okay, I'm not going to spend a lot of time on this. If you are interested in this, I will put my slides up at the end of the week and you can go and have a look. There are a lot of progression models around the world. There's one that's used in Australia and is now being used in Ireland and the UK, which was developed in Australia, which is very detailed, but it's actually very time consuming because it suggests that you do one-to-one interviews with your children to establish where they are. Who's got time to do that? Not us. No, not us. Okay. We don't have time to do one-to-one stuff. This, however, is very useful for people who are researching children and how they learn their mathematics, because you can interview them one by one. But for practicing teachers, it doesn't work so well. Then there's this team from the Netherlands who have actually written a whole book on on children's learning trajectories for mathematics, and it covers from grade R up to grade 6. It's actually quite a nice learning trajectory, but it is quite complex to understand. And then in South Africa, we've had a few people who have worked with a number of different models, and they've pulled them all together, okay? And using different work from different people. But what is common across all these different examples is that everybody talks about similar stages for the learners to move through their mathematical learning. They just use different words and different terminology as they go through. So as a researcher, I have used a lot of these things to make sense of the children that I've worked with. But over time, I've come to, when I've been working with teachers, I've come to just to look, I need something a bit simpler, something that we can see and work with quite quickly. Okay, so in the foundation phase curriculum, there is a small progression process, level 1, 2, and 3. And this is learning for foundation phase learners, obviously. The first phase is children who count everything, normally with tally marks and with their fingers. The second one is about counting on from a bigger number. And then the third level is about breaking down and building up numbers. That's the level of working with number sense and working with numbers in a flexible way. But doesn't say too much about how, okay? So what we've developed is this thing that's called a spectrum. So for us, it's taking all this work and it's putting it into a visual format so that we can actually see what this learning pathway is for our children. It's a lot more detailed about that level 3, and it can be set up for a particular task, for like one question, or it can be set up for an operation like addition and subtraction or fractions. Okay? So it's quite a flexible way of thinking about how learners would progress through a particular task or through learning. Okay, so we first presented this at AMESA in 2012. my colleague and I, Professor Graven, we first presented our procedural fluency spectrum in 2012. And there is a lot of work, there's papers and so on that you can read that will show you where we came, how we came to that. But what I want to look at first is to say, okay, I'm talking about a spectrum. What is a spectrum? So it's a visual thing. So this is something that you might see when you fill out a questionnaire. At the left-hand side, it says totally disagree, and at the right-hand side, it says totally agree. Okay, have you seen something like that before? Okay, all right. So it's very visual, and it goes from one side to the next, normally from left to right. Okay, so I want you just quickly to do a task for me in your head. I want you to add 10 to 92. And I want you just to notice how you worked it out. Seems easy for us, hey? Oh, it's not working. Have we got tech support here anyway? No. None of my pictures are showing. Yeah, thank you. Okay, so how did we add 10 to 92? How did you do it? Sorry? Use the pattern of 10. So what did you get for an answer? Okay, 102. All right. Did anybody do anything different? Okay. I'm going to pretend that I'm a foundation phase learner, or maybe an intermediate phase learner, okay? And I might start with 10, and then start with figuring out a way of adding 92. How would I do that? I might draw lots of little tallies, yes? Or I might just start drawing tallies to start with and say, okay, straight from, let's go, 10 and then 92 of them, and then count them all up, okay? Something a little bit quicker. Sorry? Okay, so they could make sets of 10 and then add those up and count in 10, 20, 30, 40, and so on. Yeah. Another way would be to turn the numbers around and say 92, which is the biggest number. Then I can either use my fingers or tally marks to work out the rest. 92, 93, 94, 95, 96, 97, 98, 90, etc. Yes? Yes, my pictures are not showing. Which pictures? They're showing here, but they're not showing. So none of my pictures are going to show, and it won't work. My presentation won't work. Okay, I think, yeah, we're going to have a small break because I can't continue unless you can see my pictures. So, just thinking about those methods that we've just talked about really quickly, which ones do you think would be the slowest or the least flexible type of method? The ones that are drawing tallies, okay? They're not also going to be the most exact. They're not necessarily going to give us a correct answer, okay? Because we have to type so many, we have to draw so many tally marks. What would be quicker? What would be the most efficient way of answering 10 plus 92? Okay, bigger number first and adding the smallest one, or just using the pattern, knowing what happens when you add 10 to a number. Okay, so already, just with a simple example like that, we have an idea of what goes at the far hand of the spectrum is the slow and the more inefficient stuff. Okay, at the far right is to try and get our children to understand how to add 10 to a number. And in between, now this is the in between, the far right is what we want to happen. We want children to add 10 to a number. How do we get from that far left to the far right? We can do things like turning the number around and counting on from the biggest one. That is a step forward from drawing 102 tally marks. Okay, it's much more efficient, it's quicker than drawing tally marks if I know that I can find the bigger number and add on from that. Okay, so that for me is progression. Okay, by moving them from concrete tallies to another method or another strategy. The next thing would be to then start to help them to understand the patterns of what happens when we add something 10 to something, okay? And we do a lot of practice with 5 plus 10, 15 plus 10, and so on, until they understand the pattern. So that when you say to them, add 10 to 92, they know immediately the answer is 102, okay? So we're trying to move them across using intermediate methods before we jump them to the end. Oh, have they been... Sorry, bear with me a second, please. I've got to try and get these diagrams to work. Okay. It's okay. I have got another version. Is that why it's not working? Because the pictures have not saved over properly. Let's have a look. Okay, they are in this one. Can we plug back in? What's happened to my screen? Okay, yay. Okay. Thanks, guys. Okay, sorry about that. So we've kind of covered this in a very unvisual way, but these are the types of responses that you get from children to that simple question of add 10 to 92, okay? So we've got the tally marks, we've got children that count up from 92 onwards, we've got a child doing 92 plus 10 with the vertical column addition. And at the bottom right here, we've got the child who just says 102 and kind of knows the pattern. So what does that look like then across the spectrum? So at the left-hand side, we've got those less efficient tally mark type methods. At the far right, we've got the child who says 102. And in the middle, we've got other intermediate type of methods, okay? Why do you think I've put option B, 92 plus 10, as an intermediate method and not a very fluent method? Any ideas? That one that says B. Okay, so it's chosen the vertical. Okay, all right. So for me though, for this particular question, 92 plus 10, it's quicker to do it in my head than it is to draw a column method, okay? But as you say, the child who doesn't necessarily want to do tallies will probably try the column method, okay? Because that's another place where they tend to be comfortable. But for some questions, it doesn't have to be done like that. Okay, so now I'm going to just skip through things. In our project, we have done a lot of research with spectrums, and we've used them a lot in our research work. What we've then come up with is some spectrums that we use in our teacher development program with the teachers who work in the clubs. And we've put these together so that the teachers can assess the children with an assessment, and then they can find out, using the learner's methods, where the learner fits along the spectrum. Okay? So the first spectrum is addition and subtraction, and the second one at the bottom there is multiplication and division. So let's have a look at them. The addition one starts with constrained methods on the left-hand side, so using fingers, drawings, tally marks, anything that takes time and is very concrete based. At the far right-hand side, we've got, sorry, I'm having a bad day. The bottom one is actually addition and subtraction, sorry. They know their addition and subtraction facts, and they know when it's appropriate to use a column method or an algorithm. So when I say that they know their facts, they know their bonds to 10. They can work out bonds to 20. They can work with numbers up to 100. They know basic addition and subtraction facts, and they can recall them to use. Okay? In the middle then, we've got counting on, counting up, and counting down as a step up from counting everything. The third one then is about using things like doubling and halving as ways of working things out. So for example, if I know that double 20 is 40, I can say, well, what's 20 plus 21? It's double 40 plus 1, okay? So using those types of strategies, combining 5s and 10s and knowing how to work with your bonds of 5 and 10. The far right-hand side then, as I say, is where we want them to be, being able to use their facts, recall their facts,
and know when it's appropriate to answer something mentally, or when it's appropriate to try and work something out with a column method. Similarly, with multiplication and division, we always start with fingers and drawings. Then we would move on to things like skip counting in 2s, skip counting in 3s, skip counting in 5s. So if a child's doing 2 times 2 as a sum, they might then say 2 plus 2 as their way of working it out rather than drawing tallies. The third way for multiplication and division is using arrays, rectangular arrays for working things out, and splitting the multiplication sum into expanded notation. Okay, so 120 times 5 might be 100 times 5 and 20 times 5. And then the far right again is knowing your multiplication and division facts, being able to use them, and being flexible enough to know when to do a column method because the numbers are too hard to work out mentally, or being able to say, I can do this one in my head because I know how the numbers work. Okay, so those are our spectrum that we have developed over the last 7 years, working with research, working with different models that are in the literature, and working with teachers. We've come up with these spectra. So they are very much about helping a teacher to take a learner's method from an assessment and to say, my learner is here on this spectrum, somewhere. So once I know where my learner is, I can set appropriate tasks to be able to try and push them a little bit further to the right, constantly pushing them further to the right. So let's have a look at some methods that have come from our data over the years. So the first one, the green one, finger counting. Okay, we see children doing that all the time for addition and subtraction. For 8 plus 6, tally marks. 23 plus 18, tally marks. 467 minus 43, tally marks. Okay, so we all know those ones. Let's look to the next line, which says less constrained methods. So for 8 plus 6, that learner has done what? Counting on. Okay, so that's great. They're not drawing tally marks. They know that 8 is the biggest number, counting on. 23 plus 18, the child is doing some kind of place value work there. Okay? 23 plus 18, that child's also doing some place value work in a different way. Okay? 104 plus 97, place value. Okay? Let's look at the multiplication and division. Again, at the top, constrained methods. We've seen this. Counting on your fingers. For division, tally marks. And a little bit of an algorithm which is not quite right. 24 times 6, tally marks. Okay, so let's look at the second lot. Some different strategies which are slightly forward of the constrained. So the first one, children using expanded notation, breaking that down to work it out with repeated addition. Interesting one in the second column, skip counting, counting in groups, and perhaps doubling to get to the answer. Okay? The third one, repeated addition possibly, and the fourth one, dividing by allocating to groups. Okay? They're still not fast, because the child still hasn't got the facts in their head. So they're not at the far, far right of the spectrum, but they are showing a little bit more of understanding of numbers and operations with the methods that they're using in that bottom row. Okay, they're not drawing tally marks. So from an assessment, you can take examples like this And if your child that you're looking at is using a method like that, you can then say, well, where are they on that spectrum? Okay? They are mostly concrete, tally marks, or perhaps they're at a slightly less constrained level, and I can now start pushing them a little bit further to start learning their facts. What is so important for me, though, is that the constrained methods do not show any understanding from the learner. They're approaching every single sum the same way. Thank you. Once we start getting the other methods coming out, we're starting to see how this child understands. So with these multiplication ones at the bottom, we can see that this child in the first column understands that 12 is 10 and 2. And it has to be, both of those things have to be dealt with to multiply it by 4. Okay? So that child has got an understanding of place value and the understanding of what has to happen for multiplication. I can actually see that understanding on the paper. With a tally mark, I can see nothing. I can't see anything. Okay? So what I want to encourage you to do is that when you do assessments with your learners, get them to write their methods. Show their methods. Tell them they're not allowed to have a rubber in the test. Okay? If they make a mistake with their workings, cross it out. Show me your workings. So that as a teacher, you have got more of a chance of understanding what's going on here and what they are understanding. Okay? If they simply give you an answer, you can mark it right or wrong. That's it. If they show you a method, you have a little bit more insight into them. So that's my message for today, really, if nothing else. Okay? The spectrums are here for you to use. They are on our website. You can use them as you need to. But encourage your learners in a test to show their methods. Okay? So, for the teachers that we've been working with, they are using these spectra in 2 ways. They use them first to profile learners after an assessment, and then if they give a same assessment later, they can see whether the learner has made progress. And also providing useful ideas of ways to move learners along the spectrum from the left to the right. They find it very useful. So here's some examples from teachers' data. I just want to just quickly show you this one at the top. So this learner, 305 minus 97. In April 2016, look how that child was answering the question. Tallies. On the right-hand side, September 2016, how has the child answered the question? Using a number line, jumping along a number line. Okay? And this time has got correct answer. So this is an example from teachers who have profiled their children, done an assessment. This is what the child answered in April, and in September, after working and pushing the child to think differently, using a number line method. Which one shows you more insight into what the child understands? The number line. Yes, you can see what the child understands. So, what next for you as teachers? People that we are working with, our research partners in the districts and the province, are using our spectrums for doing error analysis of the grade 6 exams. So we're waiting for feedback on that to see how it works. So they're using our spectrums for addition and subtraction. Does it work for the analysis of error? So we're waiting for that. But what I want to encourage you to do is to try and assess your learners using a spectrum. Design your own spectrum. If you're an intermediate phase teacher and you're working with fractions or decimals or whatever, what is the learning process that a child has to go through to learn fractions? So they start by doing things concretely, what would be the next chunk, and what is the desired end result? Design your own spectrum. Design your test, get the children to show their methods, see if you can profile them along a spectrum. You're welcome to use ours, but you're also welcome to design your own, obviously, if you're in the different grades. I think that's it. Thank you very much for your time and for putting up with my nonsense.
Thank you, ladies and gentlemen. Let's sit for a minute and respect the speaker. We need to honor Debbie for the work that she has done. Can you join me in giving her a round of applause for the kind of work that she does? On behalf of the National Council and the LOC, they would like you to have the smalling token for accepting this invitation to present here.
Thank you. Thank you, Bossy. Thanks so much, everyone.
Thank you, Debbie. Thanks. If you like the work that Debbie is doing, please join Debbie later today at 16:35 in room 350027. At 16:35, you can actually learn more. You can assist your learners not to use this type of counting and count off. Our total was going to be
Thank you. Sorry, obviously when I saved it onto my hard disk out of the cloud, the images didn't go, and they were in the bit at the bottom, but they weren't. I was thinking, how can I do this? It's a visual presentation without. Thank you. Sorry?
It was easy to fix it.
Thank you.